Okay, what do you guys want to answer for this first part up here? Defining a buffer and stating its purpose, or stating its purpose in the definition. What's it supposed to do? What's a buffer supposed to do? That's it. There isn't anything else to it. It stops pH from changing. All right, so we want to show how the sodium hypochlorite is going to change the pH. So if I take a sodium hypochlorite, what does it do when it hits water? Is that good? It dissolves, so immediately gets sodium ions and hypochlorite ions. Now what? Do the sodium ions do anything in the water? Why not? They're what?
Spectator ions?
Yeah, why? Why are they spectator ions?
Because they're happy to.
Okay, that's a way. They're strong electrolytes though, right? Meaning they don't want to be connected to anything. So because they're strong electrolytes, they stay in their ionized form. But what about the hypochlorite? What's its issue? What about more than just the negative charge? What does it want to stick to? It wants a hydrogen. So it's in water, so where's it getting its hydrogen from? From the water molecule. And when that occurs, I get hypochlorous acid and hydroxide ions. So how does this change the pH? Goes up, right? I added hydroxide to it, basically. The hypochlorite made the pH rise. So pH is going to go up. All right, so we have 30 milliliters of 0.15 molar sodium hydroxide, 600 milliliters of water. What's the resulting pH? So to calculate pH, I need the hydrogen ion concentration. What I have here is the hydroxide ion concentration, which is fine, because if I take the negative log of that, then all I need to do is subtract from 15 and I'm good to go. Or 14, sorry. We can run this as a dilution equation, or we can calculate out moles. It doesn't really matter. So initially, let's just use the dilution equation. M1 V1 equals M2 V2. And my initial concentration is 0.15 molar. And my initial volume is 30 milliliters. And that's going to equal, I don't know what my new concentration is going to be. And my new volume is going to be 630 milliliters. Are we okay with that? Because I'm dumping this 30 milliliters into 600 milliliters. All right, so then I'm going to rearrange this. I'm going to get 0.15 times 30 divided by 0.630. Or no, not 0.6, 630. Yeah. And that's molar, and this is milliliters and milliliters, and the milliliters cancel out. So does somebody have a concentration for me? 0.15 times 30 divided by 630?
0.007.
Sounds good. 0.007 molar. Okay. So if I take the negative log of 0.007, what do you get? 2 point something? Alrighty. 2.15. Great. Are we done? No. What do we just calculate? We calculated the pOH. So then all I need to do is go 14 minus 2.15, and I get 11.85. There's my pH. The next question is exact same thing, nothing different. So I'll M1V1, M2V2, and I'll say 1.75 molar times 3 milliliters equals, I don't know, times 875 milliliters. And so I can go X is equal to 1.75 molar times 3. Oops, this is not right. That's 78. My bad. 78 milliliters. And then I've got 78 milliliters. So the milliliters will cancel with those milliliters. And do we have a concentration here? Well, there's got to be 0.006. Negative log of 0.006. Uh, 11.78 for my pH. Okay. What do you have for a titrate explanation of titration? There were some incorrect responses on the forum about what the purpose of a titration is. It is not to calculate the pH of something, it's to calculate the concentration of something. If I wanted the pH, I would stick a meter in it and read the pH, or put a piece of pH paper in there and tell you what it is. I want to know the exact concentration of the substance that I'm looking at. So explanation of the titration is use of a solution of known concentration to determine the concentration of an unknown solution. That's pretty much it. So I've got a solution whose concentration I know, and then I allow them to react with each other or mix with each other until something happens, and then that something happens indicates as an indication of when I should stop, and then I can do a calculation to determine the concentration of the unknown. Draw an example of a titration curve with a strong acid and a strong base. Okay, so we've got volume of base, probably in milliliters, and over here I've got pH, and I would have a curve that looks something like this, and at this equivalence point right here, that would be my pH of 7. Something like that. Any questions about that?